The health monitoring platform is an IoT-based system designed to monitor both patients' medical parameters and their home environment. The platform has two main purposes. The first one is to simplify the monitoring of certain medical parameters by doctors, and the second one is to automatically regulate the temperature and humidity levels of patients' rooms. The use case diagram shows how the various microservices communicate and interact with each other. The solid black lines indicate an HTTP communication, while the red dashed lines represent an MQTT communication. In the next slides, each component will be described in detail.
The catalog is the backbone of the platform. It handles a catalog.json file where information regarding patients, devices, services, doctors, as well as general configuration is stored. It is a REST web service that behaves as a server that exposes this information to clients using the request-response approach. It accepts four types of requests: GET, POST, PUT, and DELETE. POST is used by devices and services for adding themselves to the catalog, as we can see in the video. It is also used by the Telegram bot for adding new doctors as well as adding new patients. Once the information is present on the catalog, each microservice will update its own information by using a PUT request. To prevent several requests modifying the catalog at the same time, a thread lock has been implemented. This avoids any problems in the handling of the .json file. Whenever a service requires some information from the catalog, it will simply perform a GET request and the catalog will respond with the information that was requested. Another important actor in the platform is the device monitor. It has a very straightforward goal, which is making sure that all of the devices present in the catalog are indeed active. It uses a simple yet robust reasoning. It starts by sending a GET request to the catalog to access all of the devices' information. Then, using a for cycle, checks whether each device was updated sometime in the past 120 seconds. If not, it sends a delete request to the catalog for that device. Once this is completed, it waits for 90 seconds before it starts the procedure again. In the video, which has been sped up, we can see how after stopping two of the devices, the device monitor sends a delete request, and these devices are consequently removed from the catalog.
Health connector is a device connector that implements MQTT transmission of two kinds of simulated data: heart rate and blood oxygen saturation. Simulated heart rate data follow a Gaussian distribution centered on 70 bpm with a 3 bpm standard deviation. Regarding the blood oxygen saturation sensor, the simulated data follow also a Gaussian distribution with 98% of mean and 1% of standard deviation. Health Connector exploit the SNML format to send data through MQTT protocol. Both kind of data are sent within the same message with the topic Poly IoT project sensors. Then there is the number of the device ID and health. Health Connector communicates with the catalog to register and update device information, but also to check if the device has been activated, so associated with the patient. And also with the ThingSpeak adapter to send the recordings always through a message broker. A home connector is a device connector that also implements MQTT transmission of two kinds of simulated data: temperature and humidity. Here we can see the temperature Gaussian distribution centered on 22 degrees Celsius with a 0.5 degrees standard deviation. In the humidity sensor, the simulated data follow also a Gaussian distribution with 50% of mean and 5% of standard deviation. For each simulated data in this platform, to ensure small variation between following generated data, every time the new value is equal to 0.9 times the previous value plus a 0.1 percentage of the generated data. The health connector, home connector, also exploits SNML format to send data through the MQTT protocol. Both kind of data are sent within the same message with the topic, Poly, IoT project, sensors, the number of the device ID, home. Home connector communicates with the catalog to register and update device information, but also to check if the device has been activated, and to the ThinkSpeak adapter to send recordings through the message broker. Also, there is the timer control, that is the automatic manager of the temperature and the humidity of the room. And the microservice is the timer control. It follows the logical principle explained in this flowchart. So, for both variables, it receives the message. If the variable is out of range, the range specified by the patient, we increase the counter a counter. When the counter of temperature values or humidity values out of range exceeds 5, we send the actuation command, so it activates the heating system or the humidity system. The control also exploits SNML format to send the actuation messages that are the results of the analysis of the received on parameters. Timer control communicates with catalog to register and update its information, so the services information, and to the on connector to receive the recordings. ThinkSpeak adapter is one of the most important microservices in this platform because it manages the communication with ThinkSpeak database. It exploits both REST and MQTT communication protocols since it communicates with 5 different kinds of microservices. We have the catalog to register and update the service information through REST communication, the statistic provider to handle data requests from the statistic provider and return the data stored in the database, also through REST communication. The ThinkSpeak database, because the ThinkSpeak adapter sends and store in the database the data received from the connectors and retrieves the data requested from the statistic provider from the database. The health connector or health connectors to receive recordings from the connector that will be stored in the database and after analyzed. This communication happens with MQTT protocol. The same to the home connector because also data received from the home connector are stored in the ThinkSpeak database in another channel with respect to the health data.
The statistic provider is used to send a PDF file containing the requested medical data to both the doctor and the patient. To do this, the data are first retrieved from the ThinkSpeak adapter and then processed to generate a report in PDF format. As user interface, we decided to develop 2 Telegram bots. The first one will be used by the doctors and the second one by the patients. At first access, the doctor must register himself by entering his first name, last name, access code and password. Then the doctor can register his patients on the platform and join each patient with their devices, both those related to medical data monitoring and those related to smart rooms. Finally, it will be possible to view the PDF report requested from the statistic provider via HTTP request, containing medical parameters and statistical information about the monitored patient's medical data. All the data concerning the doctor's and patient's information is communicated and saved to the catalog via HTTP request. On their side, the patient can access the platform after being registered by the doctor. After the login, the patient can add smart rooms, modify minimum and maximum temperature and humidity parameters of the rooms, and view the PDF containing their medical data and statistics.